Okay, we are recording, so we will get started. Today, we are going to talk about recursion again. Hopefully, clarify some things that were talked about on Monday, but might not have been the clearest. And then go over some more stuff. I did not yet get the practice test for test 2 out on the Blackboard. I will do that hopefully tonight or tomorrow. Plenty of time. We will talk about it next Monday. It'll be the same as last time. It's for 75 points. It'll have a true, false, multiple choice section, a short answer section, debugging section, and a writing program section. I actually have it on the in a doc in Google Pages format, but I need to transform it into Blackboard. Blackboard requires Excel to upload it or just manually input it. So we'll work on that. Let's see. Other than that, let's talk about specifically recursion. Revisiting from Monday's lecture, we had code where we were working on a palindrome. And we want to calculate whether a string is a palindrome using recursion. Now, we talked about this a little bit on Monday, but I want to go over the fact that in this case, recursion must have at least one base case and at least one recursive case, and the recursive case has to make the problem simpler. In the case of a palindrome, determining whether a string is spelled the same forward and backwards, we have 3 base cases. A string is a palindrome if it is either 0 characters long or 1 character long, and a string is not a palindrome if the first character is different from the last character. In that case, it is not a palindrome. So, for example, cat is not a palindrome because C and T are different. Those are the 3 base cases, and we can actually combine the first 2 where it is a palindrome into a single one. And I have to apologize for this, but I'm going to mute and be gone for just a minute because I've got a dog going insane in my garage and I got to let him in the house. Apologies, right back. Okay, we are back. Apologies for that. Now, my daughter moved in. My youngest daughter moved in with her dog the other day, I guess last week sometime. And now my dog is going crazy because another dog is in his house and in his space. And so we have to deal with this. So, palindromes, base cases. String is 0 or 1 character long. It is a palindrome. If the first character is different from the last character, it's not a palindrome. Anything other than that has to be addressed in the recursive case. And in the recursive case, what we're going to do is we're going to strip off the first and last characters. We're going to make a shorter string, a simpler case. Okay. If the first character is the same as the last character, okay, the length is not 0 or 1. Clearly that fails. And clearly that fails our other base case of the first and last characters not being the same. So if the first and last character is the same, then the answer we get is what we get when we throw away the first and last character and just take the substring of what's in between. So, for example, the simple 3-letter word yay, remove the first character, remove the last character, and look at what's left. And we have the 1-character string A, and by our base case, a 1-character string is a palindrome. So this is a fairly simple thing. The pseudocode, again, we talked Monday, but I want to walk through it, make sure it's clear. What we're going to do is check to see what the length is. If the length is not 0 or 1, so if the length is longer than 1, we're going to check to see if the first character equals the last character. If the first character in our string is equal to the last character in our string, then we are going to just take the substring created by throwing away the first and the last character. Now, obviously, in a zero-length string or a string of length 1, if you try to throw away the first and last character, you're going to get a fatal error because you're going to have an index out of range and things aren't going to work properly. And so we have to do that check first. But we've done the check. The string length is longer than 1. We check to see if the first character equals the last character. If it does, in this case it does, we create the substring by throwing away the first and the last characters and just take x from 1 to -1, or if you prefer, x from 1 to length of x minus 1. Now remember the list syntax and how this works. Whoops, apologies. X from 1 to -1 says throw away 0, right? Throw away the first element in the string because that's sub-0, and go all the way to, but do not include -1. -1 is shorthand for the last element in the string. Or if you remember, -1 is just a shorthand for length of x minus 1, if you want to put it out there and be clear that way. So the substring from 1 to length of x minus 1, or just 1 to -1, is the substring that you get from throwing away the first and last characters and leaving the stuff in the middle. Okay? So in the case up here where we talked about x equals the string yay, y-a-y, it fails our base case. We check to see if the first character equals the last. They do equal. We throw them away. We're left with a one-character substring, and by definition, a one-character substring is a palindrome, so the whole string is a palindrome. If I start with a string at an even number of characters, so for example, the string tt, y, the variable y is just equal to the string tt. Okay, it's not of length 0, it's not of length 1. Check to see if the first character equals the last character. In fact, in y equals tt, they are the same. Throw them away. When we throw them away, we have an empty string. An empty string, by definition, is a palindrome. So what we're doing here is the reason we have to have these two base cases of the string may be 1, and that's a palindrome, the string may be 0 and a palindrome. If we are throwing away 2 characters every time, if we're always deleting the first and the last characters in a string, if we start with an odd length string, a string whose length is an odd number, and it is a palindrome, we wind up with 1 character left. If we start with a string that's an even number and we throw 2 characters away every time, we're going to wind up with an empty string. So those 2 base cases of a 0-length string and a 1-length string, both being palindromes, those 2 base cases are needed because we might start with an even-length string or an odd-length string. We don't know. Now, let's go into PyCharm, and I rushed through this last time. I want to go through it more carefully, and let's see what we can do. Okay. I'm going to get to this code in a minute. Let me get to the palindrome. Okay, so the palindrome code, the function I'm going to write is going to return a Boolean. Okay, I'm going to write something that returns a Boolean that's true if the string is a palindrome and false if it's not. It will take as input a string. Def is palindrome. It takes a palindrome string. Well, let's call it string to check. The parameter, string to check is the string that is or is not a palindrome. And we're going to return true or false. Okay, so here we go. In is palindrome. Our base cases, if length of string to check is less than 2, then return true. This covers both of our base cases. If it's 0, if we have an even length string and we wind up at 0, we're covered. And if we start with an odd length string and we wind up at length 1, we're covered. So in this single string, I've covered both cases. I could clearly also have said length of string to check equals 0, or length of string to check equals 1. Logically, this is the same thing. Because I know a length has to be a non-negative value, you can't have a negative length of a string. I know this is fine, so I'll use this one. Anyway, getting back to the actual code. Now, the else, I also have to look at string to check whether the first and the last characters match. Sub-0 equals string to check, and again, just -1, the last character. And in this case, it's a base case, so I don't need to be equal. I need to be not equal. This is not a palindrome. If the first and last characters are not the same, this is not a palindrome. I return false. Now I'm at else. Okay, I know the length. By this, I know the length is 2 or more. By this, I know the first and last characters match. So now I'm in that situation where I'm going to check to see whether the substring is a palindrome. Okay, I'm going to write this expression in a couple of steps. We'll get there. Just stay with me. I want to call isPal on string to check sub-1 to -1. This is what we just talked on the slide. This is the recursive case. Check to see if it's a palindrome. It's going to be true or false. This is the substring. I've thrown away the first. I've thrown away the last. What I'm going to do is I'm just going to return this value. Okay. Whatever the value of calling the function recursively is, I'm going to return it. And we're going to go through. Okay. So this is my function that is going to check to see what a string is, and it's going to recursively call itself. It's going to check the base cases, and if it's not a base case, it's going to recursively call itself, and then it's going to return whatever answer I get. Now, let's write a real quick main program to go with this. If name S equals input, what string do you want to check? Answer equal is pal of S. Print answer. All right, so let's run that code and find out if I made any syntax errors and see what it works. Go to a console, not a terminal. What string do you want to check? Well, let's go with one that is a palindrome. This doesn't have to make sense, but we'll make sure that we have one, which is LAGHT space THGAL. That should be a palindrome because it's the same letters forward and backward. And it was deliberately caught. And let's see what happens. And indeed, it returns true. Now, let's see where we are using all the capabilities of our IDE, our Integrated Development Environment. We're not going to use the debugger yet because we haven't really covered that. What I want to do is I'm going to step through. I'm going to go back to my function, and I'm going to, first of all, I'm going to fix that spelling in my comment. But now what I'm going to do is I'm going to say print in is pal with string, comma, string to. This is going to let us see exactly where we are. Okay. All righty, let's see. Another nonsense string that just happens to be a palindrome. QWERTY space YTREWQ. Okay. Now, this may help explain what's going on. In the main program, I input the string and I call isPal, and string to check has this value. Now, the first character, Q, is equal to the last character, Q. So what we do is we recursively call the function with this string. The Q and the Q were thrown away, and this is what's left. Now, the W and the W match, so we throw them away, and we recursively call the string here. The E and the E match, we throw them away. We recursively call the string here. The R and the R match, we throw them away. Here, we've got this string left. We throw them away, the T's, that is, them being the T's. We throw the T's that match away, and we have a string Y blank space Y. Throw the Y's away, we now have a string which consists of a blank space. It's hard to see, I probably shouldn't have used a blank space, but we have a blank space right there. And so now when we're in the function, we go to the base case, and the base case says, yes, this is a string of one character long, and it's a blank space, and that means it's a palindrome. So we return true. And it returns true all the way up through each function, each iteration of the function. So let me see if I can make that a little bit clearer. Here. Sorry, this would be false. Okay, let's run that and see if we can follow what happens. Okay. Now we can see that we get all the way down here and we're returning true. And that goes up through the program and goes through each call. Okay. Returning true. If I wanted to lengthen this code, I could probably put in another thing, but hopefully you're getting the idea of what is happening. We are recursively calling the function We recursively call the function. We're doing this, we're making it simpler. We're making it smaller. Remember, the requirement for the recursive case is that each successive call has to make a simpler problem, a shorter string. We have to get closer and closer to a base case. If we never get to the base case, then what's going to happen is we're in an infinite loop. Now, every Python interpreter, GL, PyCharm, whatever you want to do, Python on your Windows box, whatever, has a maximum number of recursions. The reason being that recursions take up a lot of resources on your computer. And so everything by default has a maximum number of recursions, which if you hit, it's going to stop your program from executing. And I'm going to demonstrate it in a minute. And I just realized I didn't bring it in. Okay, here we go. So let's import the sys module. And what we want is sys.get recursion limit. And this tells me that on PyCharm, the way I have it configured right now, the answer is 1,000. Okay. If I run a program that tries to recurse more than 1,000 times, the program will stop, okay, because I'm consuming too many resources. You can look it up on GL and see what it is. If you really have to have something bigger than that, okay, I mean, in general, anything you're going to be doing in this class, anything you're going to be doing, almost anything in a college level programming class, you're not going to be recursing 1,000 times. I mean, that's horrible. You could, just for kicks to see it, if you hit this recursion limit, in all likelihood, you've got an error, you're in an infinite loop. You're in an infinite loop of recursions. And so this recursion limit is what stops you from consuming all the resources on the system and running forever. But if you really need to, you can set the recursion limit. And let's make it 10,000. Just because. Now, if I really am writing a program, I cannot imagine one off the top of my head, but if I really am running a program that needs to recurse, to call itself recursively 10,000 times, I can do that. That's how. Just as that's a little heads up when you're programming recursively, if you get an error that says, you know, your program stops because your maximum recursion limit exceeded, this is what triggered it. This variable, whatever value was exceeded. And mostly that means you got an error and you need to go back and make sure that your recursive case, in this case, your recursive case being right here, is actually making it simpler, not failing. Just for kicks, what we're going to do is we're going to deliberately cause an infinite loop. Now, before I do that, I'm going to go back and set, so I don't take hours and hours waiting, I'm going to set my maximum recursion limit to 10. At the recursion depth 11, what am I doing? Limit is too low. Okay. Oh, let's make it 20. Okay, I'm going to kill this console and start over because it's probably confused. That tells me my maximum recursion depth is exceeded in whatever program is running right then in the file, okay? So just the system I'm loading, 20 is too low, so let's try this. Make sure that's working. Boy, try to force an error in Python PyCharm doesn't want you to do it. Here we go. What string do you want to check? Now is the time emit EHTSIWON. Here we go. This is what I was actually trying to illustrate with this. Because I had written the code, so I deliberately did not change the string, you can see that what happens is the string is the same every time. When the string is the same every time, I never get simpler. And so the way PyCharm and the way GL and the way the other Python implementations handle it, I'm eventually going to get to the point where I've exceeded the maximum recursion depth. The way to handle that, if you really, again, generally, if you see you've exceeded the maximum recursion depth, it means you've got an infinite loop. Go back and fix your code. But if you really, really are running something that takes forever and ever and ever, then what you need to do is change your recursion depth. Since I've got to post this on GitHub for you all to use, I think I'll make it legit so the code actually works. So that is the code for palindrome. A little slower, a little more careful, a little more detailed, and hopefully more understandable than when I was rushing through in the last 2 minutes on Monday. Okay? So let's move on to the next thing. Now, the next thing I want to do is talk about, you might have seen the code when I was in PyCharm, homework problem 2. Okay? Homework problem 2 is worth homework 6, the one that's due next Monday that you're working on. Homework 6, problem 2, the problem that's labeled hard, asks you to balance curly braces. Now, you have to write it recursively. It's labeled hard. If you understand the problem, it's not actually that hard. What I'm going to do is I'm going to show you an iterative solution to make sure you understand the problem that's actually being asked for. You should then be able to write the recursive solution to that problem, because we'll talk about what might be the base case and what might be the recursive case. So here is the pseudocode. This is my description of what you're being asked for in homework 6, problem 2. Okay. Again, we're going to go with an iterative solution, but the general idea is similar. We're going to write a function that takes a string. We're going to pass in the string as a parameter. Okay, cool. The function takes one parameter of type string. We are going to keep count of the curly brackets in the string. Now, we are only going to count how many we still need to balance. So we're going to initialize the count of curly brackets to 0, right? When the function starts, we're going to initialize the count of curly brackets to 0. And then in the iterative solution, we're going to start a loop. And in the loop, we're going to process one character of the string. Okay? Each character of the string in turn in a loop. Now, if it's a left curly bracket, we add 1 to our count of curly brackets. If it's a right curly bracket, we subtract 1. If it's any other character, do nothing. It's not a curly bracket, we don't care, because we're only counting and balancing curly brackets. So, left curly bracket, add 1. That means we have to balance 1 more to make this work. Right curly bracket, subtract 1. That means we have matched 1 and we no longer have to worry about it. Any other character, we don't care. It doesn't match any curly brackets. Now, Here's something to think about, and this was a hint in the homework assignment, and this is what it means. What happens if that count ever becomes negative? Okay. If that count ever becomes negative, that means you have seen more right curly brackets than you have seen left. Okay? Because when the count is 0, you have seen exactly the same number of lefts and rights. Initially, first time through the string, first character, count is 0 because we've seen nothing. We see a left, it goes up to 1. We see the right, it goes to 0. We see a left and a left, it goes up to 1 and then 2. We see a right, it goes down to 1, and a right, it goes down to 0. Anytime the count is 0, you've seen the same number of lefts and rights. If that count ever goes negative, it's because you were at 0, you were balanced, and you saw a right. Well, think about it. If you see a right before you have a left, you can stop right then because you know this is invalid. You know you have seen a right before you saw a left. This is an invalid expression. There's too many curly brackets of the wrong type. Okay, there's too many rights. And so if this count, this is one of the reasons you're keeping this count. I'll tell you that in a minute. One of the reasons you're keeping this count is because if that count ever goes negative, then you know you have seen a right curly bracket before you've seen its left, and therefore you can stop and return false because this cannot be a valid string. If the count ever goes negative, this cannot be a valid string. You can stop what you're doing and return false because there's just no need to go on any further. So that is one reason you are keeping the count of lefts and rights. If the count ever goes negative, it's an error. Now, if the count never goes negative, it's always 0 or positive, then you will go all the way through the string. When you have looked at every character in the string, look at your count. If the count is 0, okay, if the count is 0, remember what the count being 0 means. It means you have seen the lefts, same number of lefts as rights, and that means it balances. The string balances if you've seen the same number of lefts and rights, and therefore its value is 0, and you have never seen a right before it's left. You've always seen left first, then right, and then when you're done, the count is 0. So when you're done, if the count is 0, you're going to return true because this is a valid string. The curly brackets balance and they're in the right order. Otherwise, you're done and the count is not 0. Remember, it can't be negative. We've already checked to see if it's gone negative. If the count is positive, it's greater than 0. We finished the string. We had one or more lefts without a right. That doesn't balance. That's invalid. So return false. So what we are doing in problem 2 in homework 6 is going through a string. And in that string, what we are doing is keeping count of left curly brackets and rights. We start at 0 because we have seen the same number. We have seen none of each. Every time we see a left, we go up. Every time we see a right, we come down. At any point, if we ever go negative, that's invalid because we saw a right before it's left, and so we stop and say, nope, not valid, false. When we are done, when we have processed every character in the string and the count never went negative, then we look and see. If this is a valid, syntactically valid string, what will happen is our count will equal 0 because we've seen the same number of lefts and rights. Same number of lefts and rights means the count is 0. Okay. If the count is not 0, it's greater than 0, it's some positive number, this is not a valid statement because we've got more lefts than we've got rights. So this is the pseudocode, this is the description, and this is the code that we want to write. Now, I think I go straight to PyCharm, and I'll post this. This is the code I wrote to do that, to implement an iterative solution. Again, in homework 6, you're going to write a recursive solution, but you should at least A, understand the problem, and B, have some ideas, and we'll talk about it. Now, we have a function. It takes in a string. It's called bracket string because a string includes curly brackets, baby. We initialize the count to 0. Now, process the string character by character. We talked about that, one letter at a time. If the character is a left curly, add 1. The characters are right curly, subtract 1. And if the count ever becomes negative, return false. Here is a loop to go through the string character by character. For I in range of the length of the string, okay, for each character in the string, look at it. If bracket string sub I is a left curly, add 1. If bracket string is a right curly, subtract 1. Otherwise, you do nothing. We don't need that. You can write this with 2 ifs. I wrote it 2 ifs because it seemed more clear to me what was going on. You can write this as if else's, nested ifs, if elif, whatever you want. It all works out. This is the logic you have to do. If this, you do that. If this, you do that. Otherwise, you do nothing, so I don't have to write any code that says do nothing. Now, I do have to check. I'm only going to check when I see a right, okay? I only have to worry about the count going negative if the count was 0 and I subtracted 1. Because all I'm doing is adding 1 and subtracting 1. The only way the count can go negative is if it was 0 and I subtracted 1. So within this part of the code, if I saw a right and I subtracted 1 because of the right curly, I check to see if the count's negative. If it's negative, I return false right then. And that will break me out of the loop. Remember, functions. Functions in Python, as soon as you execute a return, you're done. It will not matter that there are still letters left in my string. It will not matter that I've got, lots more to process. As soon as I execute this return, I'm done. That's okay. The rest of the string will just be forgotten. It doesn't matter. It's an invalid string as soon as we see that right curly bracket that's out of order. So that's what we're dealing with here. For each letter in the string, if it's a left, add 1. If it's a right, subtract 1. If you subtract, check to see if you've gone negative. If you've gone negative, return false. You can stop. Now, this loop has ended, okay? This for loop has ended. We have processed the entire string, and we never went negative, so we drop out of this, okay? If I drop out of this loop and go down to the next line of code, I can safely assume that the count never went negative. Because if it ever went negative, this return statement would boot my tail back to the main program, and I would never get here. I would never see this. So if I get to here in the code, I can assume I've finished processing the string, and the count never went negative. So now what I have to do is determine whether the count is 0 or positive. If the count is 0, the brackets match. If the count is greater than 0, then they didn't match. We had more lefts than rights, and I've got to return an error. So at that point, the logic is fairly simple. If the count is 0, return true. Otherwise, return false. And we're done. So this is the function that implements iteratively what you're doing in problem 2 in homework 6. Okay, so let's come down here. And now we're just going to do a main program. We're going to call it, okay, iterative, if I can spell, bracket, match, with the string, left curlies, base, now here, right curly, this right curly. Okay, and let's see. And indeed, it returns true because I went left, left, right, right. No rights ever before a left. And there were 2 lefts and 2 rights. So we started with an easy one. Now, let's put an illegal right first. And let's exercise our function and see that this indeed returns false. And it returns false because I had a right before a left. So I dropped out and we're done. Now, let's take that illegal right out. Let's put just put a left in front of it. And now let's put another extra left in front of it. Now, if you count, I have 1 left, 2 left, 3 left, 4 left. I have 1 right, 2 right, and 3 right. So this should give me false. This is not a valid string because I have too many left curlies and not enough rights. So let's make sure this works right. Let's test this. And indeed, false. Remember for the exam, test as you go. Test as you go. Write the function, test it. Does it work right? Does it give you the answers you expect? This is a description of the problem that you're addressing in problem 2 of homework 6, and this is an iterative solution. Now, let's think. I can't give you the answer because it's also what the majors are doing, and Hamilton and Wilson would not be happy with me if I gave them the answer. But let's think about how you do this recursively, right? In the function, in the recursive bracket match function, you have to have a base case. Well, one base case is the string has been fully processed. Okay? If the string has been fully processed, the string is of length 0. Boy, I can't spell today. Was up too late last night watching election returns. If the string is of length 0, then that's a base case. The answer is either true or false, depending on what the value of count. That is a base case. The base case is if string is of length 0. Now, is there another base case? Sure. Remember that if the count ever went negative, we could drop out immediately and return false. There was no more processing. That's invalid. If count is negative, we know we have to return false. That seems like a decent base case. So we did talk about recursion. You can have multiple base cases, and here seem to be a couple of base cases that we might have to think about. Now, recursive cases, well, recursive cases simply seems to me to be an easy one is remove one character and check the rest of the string, right? That's what we did iteratively up here, right? We just looked at one character, processed it, and looked at the rest of the string. We moved on in our loop. Well, you know how to do that recursively, right? We just talked in the previous palindrome example about how to call the function recursively with a shorter string. You just take the substring and call it that way. I should say, remove the one character, process it. When I say process a character, in that case, it says check to see whether it's a left curly, a right curly, or something else. If it's a left curly, add 1 to count. If it's a right curly, subtract 1 to count. If it's something else, do nothing. So that's what I mean by process a character. Decide if it's left, right, or nothing, and based on whether it's left, right, or nothing, decide whether I have to add one, subtract one, or do nothing to the count. So that seems to be a recursive case. So with that hint and no more, you should have a good handle on doing the hard problem on the homework, problem 2, which is processing strings that contain curly brackets, lefts and rights, and checking to make sure whether they're valid or not. They are valid if the lefts and the rights balance and they come in the right order. They are invalid if there's more lefts than rights, and they are invalid if there's ever a right without a left. Okay. That's part 2 of what I wanted to cover in lecture tonight. Part 3 is I wanted to cover, again, something I think I did poorly on Monday, which is how Python is handling memory and handling access and handling scope of variables and stack frames. So this was my quick and dirty solution to project 1. Your project 1 that you submitted earlier this week, or last week if you were working fast. Okay, this is quick and dirty. It just has code. It doesn't have a lot of comments because I was testing it to make sure I got the right examples, and I just did comments where I needed them. Okay, my solution without a lot of comments was 88, let's call it 90 lines long. Wasn't too bad. Okay, I had a number of functions, the ones you had to have: standard deviation, mean, median, read file, create lists. And now I go into the main program. This doesn't have everything, but it's good enough. Okay, to illustrate what I want to illustrate. Now, here's what I wanted to talk about that I used the. I get out of this. I'm going to need the be able to write to modify this. When I used the website to illustrate what was going on, I realized as I went through it that was probably less clear because I didn't have the opportunity to stop and walk around the classroom, explain everything. So hopefully we're going to do it better. This is how Python manages memory, and this is how things work. Now, project 1 was an iterative solution. So what I want to do is show you how Python handles an iterative process. Okay, when the main program starts, the main program executes, you start declaring variables, you have functions defined. Python that didn't work right. Let's undo that. Python says, okay, when the main program starts, we will fire up memory. All right. And we will put this stack frame on the stack. So over here on the left is memory and how Python management manages it. This is going to be the stack on the left side. Okay. This tells us at any given time where in memory we are. And so Python will use its symbol table and it will write in what are the function names. Well, we know about read file. We know about create list, etc. Variables. Variables, we know about files to read. So this is where in memory that symbol table I've always talked about is going to be. I didn't have any constants, so there won't be any right now, but if there were, this is where they are. This in memory is where Python is executing right now. These are the variables it knows about, the function names, the variables, the constants, the whatever. And it executes in this main program. Now, In the main program, and hopefully this doesn't make you too dizzy, I set a value in the variable, files to read, fall 2021, fall 2020, etc. I open the file, project1 results.txt. That's where I'm going to write my solution to. This is just write some stuff. So this is all executing in the main program frame. Okay. And now what I do is I call read file. So the first thing I did in writing project one, other than some housekeeping in my main program, is I called read file. Now, when I called read file, what Python did is it has this, and this is a frame for a function. It pushes this frame onto the stack, and it says, this is where I'm working right now. And this is called read file, because that means I'm working in read file. And Python now knows, because it's at the top of the stack, that it's reading working in read file. Now, there are no functions declared in read file, but there are parameters, and that parameter, apologies, is called file name. Okay, so read file, Python knows about file name because that's a parameter. It knows about any local variables I declare. Let's see, are there any? Yeah, useless line and data. It knows about the variable useless line, and it knows about the variable data. Now, it executes. And because of the way Python manages the stack, Python knows, hey, right now I'm executing read file. After read file's done, I'm going to be back in the main program. But while I'm in read file, I know what file name is. I know what, it's fall 2021.txt. I know what useless line is. It's a string variable that I'm going to use to throw something away with. And I know what data is. Data is the string I'm going to read the valuable content in the file. Right? So this is where Python is executing. Now, read file ends. And when read file ends, guess what happens? Python says, goodbye. You are the weakest link, if you like that old show. It says, you're gone. I don't know about read file anymore because it's gone. Let's go back to the main program. In the main program, I have finished here and I have returned. And now what am I going to do? I'm going to call create lists. And Python says, oh, Arsenal just invoked create lists again. So what do I need to do? I need to put another stack frame, another frame on the stack for this function called create lists. It doesn't have any subfunctions, so I don't have any of those function names in it. Its parameters, what did I use as parameters? Its parameters are going to be class string, and now I have a bunch of local variables. So Python says class string. It has 1D list. It has proj list. It has project score, and it has a bunch of other stuff, right? All these things that are defined in create lists, it knows about in the stack frame. Now, why is this so important? This is important for the following reason. Suppose I use the variable that Python has not seen. Python has to go find it. Python will say, oh, I'll use the variable and it's not class string and it's not 1D list and it's not proj list. Gee, Where else could it be? Because there's this notion of global variables, which we're not supposed to use, but which we sort of sometimes can, okay, Python can go down here and see about variables in the main program. Now let's get back to mutable from last week, right, from last Wednesday. Mutable variables. Sometimes we won't pass in the variable as a parameter. We will just let it be, or we will just change it directly because it's being changed down here. So when we say a global variable, that means you used a variable name in a function that's not in this frame, it's down in the main program frame. Now, Python will allow you to do that. It will work. It's just bad programming, and we generally discourage it, but it can be done. Python can find anything that's in this frame or in the frame for the main program underneath it. Now, create lists finishes. I don't think, double check, I don't think I called any function from create lists. I did not. Okay. So now I do some things and I get some calculations. These are supposed to be in calc values. Getting back to how this works, illustrating my point, right? Create list goes away. It's gone. It's really gone. Python is more efficient than me. It'll kill it off at all once. What happens now is if I'm in the main program and I tried to do something with a list that was in that frame, that other frame, that frame's gone. So remember, in create files, I had a variable called proj score. Okay. In create file or create lists, I had a variable called proj score. Okay. When create list disappeared, when create list ended, and we went back to the main program, proj score disappeared, right? I deleted it. It's gone. So if I tried to use proj score here in the main program, what would happen is I'd get an error Python wouldn't know. And the reason Python wouldn't know is that frame is gone and there's nothing on the stack. So this is what I mean with a stack frame, and this is how Python works and how it finds variables. When you use a variable in a function or in the main program, it can search for it here. If it's in a particular function, it can search for it there. Oh, come on. Okay. If you use a variable, Python can look for it in the current frame, it can look for it here, and that's how it's going to find it. Now, this is how Python works with an iterative program. What I was trying to show last time with the silly website and the hokey example is how it works for a recursive program. So when we have a recursive program, get back my main program. You die. We put the frame for the main program on the stack, and we define it. Let's take the simplest case of factorial. Now, remember the factorial code just says n times factorial of n minus 1. So the factorial code we're working on just says def fact of num if num equals 1, return 1, else return num times fact of num minus 1. This is a recursive version of the factorial program. Clean up my typos. Okay. And now I'm going to do factorial of 3. I want to calculate factorial of 3. Okay, so the main program comes on, and the main program just says calculate factorial of 3. The frame for the main program starts. It says function names. I know about fact. Variables. I don't, although some variable, let's call it n. Okay, and I don't have any constants. So this is what the main program knows about. This is the stack. Now, I call factorial of 3. The main program is just n equals 3, print fact of n. This is the main program. So the main program knows about n, it knows about fact, and it calls the function. Now, let me go back and get my function stack frame. When I call factorial of 3, what happens is Python says, oh, okay, this is factorial. This is my function. And to make it clear what I'm doing, this is factorial when n equals 3. I don't have any subfunctions. My parameter is num, and num has the value 3. Okay, so now Python is executing this function code right here in this stack. It knows num is 3. It knows factorial. It knows n in the main program. What are we going to do? If num equals 1, well, is num equal to 1? No, it's not. Return 1. Otherwise, return num times fact of num minus 1. Okay. If I want to return num minus 1 is 2, I've got to call fact again, which means I have to put another copy of factorial on the stack. Now, this is factorial for n equals 2. It knows about the variable num because it's a parameter. It doesn't have any local variables. And it knows that num equals 2. So now the stack has 1, 2, 3 separate frames on it. The main program, the frame where it's 3, the frame where it's 2. Now, if num equals 1, what's num equal to? Num is equal to 2. So this is false. Let's go to the else. Return num times fact of num minus 1. Well, num minus 1 is 1. So now we call fact again. Python pushes another frame on the stack, in this case for 1, and num takes on the value of 1. Now, memory management Python stack looks like this. We have the main program. Running on top of that, we have this one. Running on top of that, we have another one. Running on top of that, we have another one. So this is a stack of frames, one on top of the other. Python is all memory managing. I mentioned to you on Monday that recursion is more intensive on the machine, more time-consuming than iteration. It's just sometimes it's simpler to think of the problem this way. This is what I meant. This is what I meant by that. Here, in this program, we have 1, 2, 3, 4 frames all in the stack at the same time. Remember, iteration, we never had more than 2, right? When I was doing project 1, I had a frame for the main program, then I had a function, and then it popped off, and then I had a function, it popped off. If create lists called another function, which it could, I could have written create list to call another function. I would indeed have had another function, another frame on top of the stack. which I could have done, I could have copied this and put another frame on top of the stack to do my calculations and so on and so on. But the bottom line is it's very simple. There's not many functions. There's nothing on the stack. I'm just going straight forward. Whereas the factorial, they're all the same function, but I've got copies over and over and over. Okay. So this is why it's a little more complex, a little more intensive on the computer, but it's easier on the programmer. And hey, today with cloud computing, the programmer, that would be you, is way more expensive than the computer, the memory, the hardware, the processor, or everything else. Trust me, you, the programmer, are the expensive part. So whatever works to make it easier for you is okay, and that's why we do recursion. At any rate, in this frame right here, num equals 1. If num equals 1, return 1. Yea, verily, it does. We hit the return, and then we pop this off. Now, where do we return 1 to? We return to the frame immediately underneath us. Just as in iteration, when a function was done, we went back to the main program because that was what was immediately underneath it. In recursive programming, when a function's done, we return control immediately underneath it. So we return to this copy of factorial where n is 2, and we return 1. Okay. This function has ended. Goodbye. We returned 1. And now we're just doing this math right here. Num times the value that was returned. Num is 2. We returned 1. That's 2. 2 times 1 is 2. And we return that value. Where do we return it? We return it right here. Okay? So this frame is now gone from the stack. And in here, return value, if I could spell return, was 2. Okay? Now, we have to do this math. Num is 3. The returned value from this call is 2. So 3 times 2 is 6. So now I'm going to return 6. Okay? So this is popped off. And the returned value is 6. So now in the main program, fact of n, the return value I got back was 6. So this just says print 6. So Python will print 6. Now, at this point, the main program is done. There is no more code in my main program. When the main program is done, this frame gets popped off the stack, and now the whole program is done, right? Now the whole program is done because there's nothing left on the stack, and so now I can consider myself done. So that's what I was trying to get across on Monday with the Hokey website with the various things put on side of it. This is how Python works. Many other languages, not all, but many other languages work similarly. Python maintains a stack, and the stack has the symbol table you're currently working with. It has the function names you currently know about. It has the variables and values you currently know about. If we go back far enough, okay, let's go back to this point, right? If you say num in this copy, in fact is 2, it tells you num is 2. Now there's another variable, num. There's another occurrence of num down here at 3, right? There's a num right here, and there's a num right here. Why does Python know that you mean 2 and not 3? Because of this stack. You only use what's at the top if you can find it. When you find this 2 at the top of the stack, you never look down here, you never look down here. Now, in fact, if you're using global variables, you could do something like that. But we don't want to do that. We want to get into it. We want to stay with this stack architecture. We want to stay with this neat design. Okay? And the design is such that we are working in the frame. The frame is this thing here in the box at the top of the stack, and you can use the variables and the values and the locations in memory that are known to that frame. You can use what's known in this frame, and you cannot get to this in the same frame. That's the same identifier. That is NUM all lowercase. NUM all lowercase. Those are the same. But you're working in this, you're not working here. You can use this, you cannot use this. Now, when this is popped off, when this function ends, and this is popped off, right, now you can use this. You cannot, the other one's gone. I mean, you can't use it. There's nothing there to use. Okay, so that is why we say it's a stack architecture, and there's frames put on there, and you only use the frame you're currently in. Global variables, yeah, you can go back, but we're not going to worry about it. Use what's in the frame you're in. So that was what I was trying to illustrate with the kind of hokey websites on Monday, and hopefully this has cleared it up a little bit. Okay. This is how Python handles memory management. That's what's in scope. That's how it finds things when you use a variable or a constant or a function name in your program. That's how it decides which is which. You could, in the main program, have called n_num. Suppose that in the main program, instead of n, I use the same variable num. Python can handle that because this num in the function is different from this num in the main program because it's in a different frame. So that was the point I was trying to get across about how recursion works. And it's a little bit different, but it's the same idea as iteration, okay, in terms of management. Now, it looks like I've got 1 minute left looking at my clock. So what have we done today? Hopefully helped with the lab and homework, especially the homework. Maybe not so much the lab, although you got questions on it, okay? But we tried to clarify in recursion how you write the code. We revisited identifying base cases. Remember, in any recursive solution, there has to be at least one base case. There can be more than one. In problem 2, I believe in your homework, it says explicitly there's 2. In addition to a base case, if you don't have a base case, program can't work. A recursive solution won't work. In addition to the base case, there has to be at least one recursive case. And the recursive case has to make the problem smaller. It has to make the problem simpler. It has to drive you toward the base case. The base case is just here's how you solve it. Here's your answer. This is what you need. Okay. Recursive, it has to be simpler. It has to get smaller. It has to go toward the base case. I showed in PyCharm what happens if it doesn't. When I didn't make the string, when I was solving palindromes, and I did not make the string shorter by removing the front and back of the string, what happened was I got into an infinite loop. I recursed infinitely, or I would have recursed infinitely, except that Python has a variable, a system variable, that will stop me when I recurse too many times. And so if you get that error, that's what you mean. When it says you exceed the maximum recursion limit or the maximum recursion depth, that means you're in an infinite loop and you're not actually changing your problem. Okay, unless it's such a very small number. So that's what that means. We talked about problem 2 on homework 6. Hopefully now you have a clear understanding of what exactly it is that problem is asking for, and you can now write the recursive version of what I gave you, the iterative solution. I gave you an iterative solution to help you understand exactly what's going on and why. And hopefully now you can write the assigned recursive version. And the last thing we did today was we talked about memory management, stack frames in Python, and hopefully cleared up what I tried to talk about Monday with how things happen in Python and the scope of variables. With that being said, next Monday, the 9th, is a review. As I said, probably tomorrow, hopefully tonight, but probably more likely tomorrow. I will get a sample exam for exam 2 out on Blackboard. Exam 2 is like exam 1, 75 points, 10 true, false, multiple choice, 3 points each, 5 short answer, 4 points each, 1 debugging, 5 points, and programming for 20 points, either 1 program worth 20 points or 2 worth 10 points each. I haven't decided, depends on how hard I think it is. 90 minutes in class next Wednesday, the 11th. And after that, we will start diverging greatly from what the majors are doing. Now, homework 6, if you look at this at the course syllabus, this is your last homework. After this homework, you just got big programming project, okay, and tests. This is your last homework. We front load the homework in the lab. We do the programming projects at the end. And I am talking too long because I've already run you a couple of minutes over. That is today's lecture. I will be around. I've got to take care of some things, but I will be available if you need to ping me, Discord, email, whatever. Lab, get that done Friday. Homework, get that done Monday. And otherwise, I will see you on Monday. Have a good weekend. And thank you much.